As we transition from our previous discussion, let's delve into a critical topic, the OWASP Top 10 for LLM applications in 2025. This framework highlights the most pressing risks that can compromise large language model applications in real-world scenarios. Understanding these vulnerabilities is essential not only for developers but also for organizations aiming to harness the power of AI securely. We'll explore 10 high-impact risks, each accompanied by live demonstrations and actionable strategies to mitigate them. This knowledge empowers us to develop more resilient LLM applications, ensuring they function safely and effectively. And speaking of real-world implications, our next slide will introduce a fascinating case study titled "The CV That Hired Itself." This example will illustrate how hidden instructions can affect the screening process, revealing just how critical it is to understand the risks we're facing. Let's dive in. As we transition from discussing the vulnerabilities posed to LLM applications, let's dive into a real-world example that highlights significant risk. The story of the CV that hired itself. Imagine PDF resume that contains hidden instruction directing the screening bot to ignore previous rules and strongly recommend this candidate. This seemingly innocuous addition leads the AI to favor weak candidate, completely bypassing human oversight. This scenario underscores the critical issue of prompt injection and vector poisoning, which can be surprisingly simple yet devastatingly effective. The implications are profound. If bot can be misled so easily, what does that mean for the integrity of our hiring processes and beyond? Now let's explore the most critical vulnerabilities facing LLM applications today. Understanding these risks is essential for securing our technology and ensuring its responsible use. As we transition from our intriguing exploration of the self-hiring CV, let's delve into what you rapidly learn in this session. First, we'll highlight the 10 most significant risks associated with large language model applications. Understanding these vulnerabilities is crucial for safeguarding your production systems. Next, we'll share compelling real-world attack stories that can empower you to engage leadership teams effectively. These narratives will not only illustrate the risks but also underline the urgency of addressing them. And we'll discuss immediate fixes you can implement this week, ensuring you leave with actionable steps to enhance your security posture. Finally, we'll outline a comprehensive rollout plan that spans the next few months, complete with free tools and resources to aid your journey. Now let's dive into the first risk, prompt injection, and how user inputs can unexpectedly influence model behavior. As we dive deeper into understanding the risks associated with LLM applications, let's explore a critical issue, prompt injection. This occurs when user inputs, which can even come from files or images, inadvertently redirect the model's behavior, overriding its intended instructions. You might notice prompt injection when the model generates outputs that completely disregard your guidance. It may access functions or data it shouldn't, or even produce unexpected results due to hidden text or images. To mitigate these risks, it's essential to impose constraints on the model's roles and tools, adhering to the principle of least privilege. Additionally, filtering and validating both inputs and outputs, along with requiring human approval for high-risk actions, can significantly enhance security. Next, we'll discuss another pressing concern, the potential for sensitive information disclosure, where models might unintentionally leak personal or proprietary data. Stay tuned. As we transition from our discussion on prompt injection, let's turn our attention to another critical concern, the risk of sensitive information disclosure. Large language models can inadvertently leak personally identifiable information, trade secrets, or proprietary data in their outputs or even in logs. This not only poses serious compliance risks but also threatens competitive intelligence. To mitigate these risks, it's essential to take proactive measures. First, ensure sensitive data is masked, redacted, or tokenized. Applying differential privacy can further protect individual data points. Establishing clear data retention policies with user opt-outs is also crucial. Remember, never hide secrets and prompts or depend on them for access control. Most importantly, educate users on the importance of not sharing sensitive information in chat interfaces. Next, we'll explore a new dimension of risk concerning supply chains in AI systems, where vulnerabilities in models and their adaptations can emerge. Building on our earlier discussion about sensitive information disclosure, we now turn our attention to a critical aspect of AI systems, supply chain risks. As AI technology evolves, so do the vulnerabilities within it. These can arise from models, adapters, datasets, and even the services used for conversion. Each of these elements introduces unique attack vectors that can compromise the integrity of AI systems. To mitigate these risks, it's essential to use cryptographically signed models, which ensure authenticity. Tracking dependencies through tools like software bill of materials is crucial for maintaining visibility on what your system relies upon. Additionally, thoroughly vetting licenses, terms, and data use policies helps safeguard against unexpected liabilities. Finally, regularly monitoring and patching dependencies, as well as performing integrity checks on adapters, can significantly bolster your defenses. As we move forward, we'll explore another significant threat: data and model poisoning, where attackers manipulate training data to introduce biases or backdoors. Building on our previous discussion about vulnerabilities in AI systems, let's delve into critical concern: data and model poisoning. This is where attackers can manipulate training data to introduce biases or even backdoors into our models. To safeguard against these threats, it's essential to curate and trust your data sources diligently. Implementing version control for your datasets helps maintain integrity. Additionally, you should sandbox all training environments to isolate and protect your models during development. Deploying systems for detecting anomalies and potential poison is crucial, along with conducting thorough red team exercises to identify hidden triggers. Testing your models with adversarial inputs can also reveal weaknesses. Finally, grounding your outputs with reliable sources reduces the likelihood of hallucinations and ensures more accurate results. Next, we'll explore the importance of proper output handling and why we must treat model outputs as if they come from an untrusted source. Building on our previous discussion about data and model poisoning, let's now turn our attention to the crucial topic of improper output handling. When working with large language models, it's essential to remember a fundamental principle: treat their output as if it were coming from an untrusted user. This means we need to take several precautions. First, always encode and escape the output for the specific context, whether that's HTML, JavaScript, or SQL. Utilizing parameterized queries is must, as they help protect against injection attacks. Additionally, implementing strict content security policy can further safeguard your applications. Finally, don't overlook the importance of logging and reviewing all output generated by the model. This practice not only aids in identifying potential vulnerabilities, but also helps maintain security integrity. Now let's explore the next challenge we face: granting excessive agency to language models and the risks associated with it. Building on the principle of treating LLM output like untrusted input, let's delve into a crucial aspect of LLM management: excessive agency. Granting LLMs too many tools and permissions can lead to dangerous outcomes. To mitigate this risk, it's essential to minimize extensions and permissions. By implementing role-based access control and OAuth on per-user basis, we can better manage what each user can do. Additionally, avoid open-ended capabilities like running shell commands or fetching arbitrary URLs, as these can create vulnerabilities. We must also incorporate human-in-the-loop approach, requiring approval for any destructive actions that an LLM might attempt. Lastly, ensure complete mediation by enforcing controls consistently across all downstream systems. As we move forward, we'll explore the reality of system prompt leakage, emphasizing that these prompts aren't secrets and require careful handling. Let's dive into that next. As we transition from the previous discussion on excessive agency, let's turn our attention to an important aspect of managing language models: system prompt leakage. It's essential to understand that system prompts are not secrets and shouldn't be treated as such. While they guide the behavior of the model, leaks can inadvertently reveal critical information, such as security guardrails or even embedded credentials. This is why it's vital to keep sensitive information completely out of these prompts. Instead, we should enforce authorization through code, ensuring that access controls are robust and reliable. Additionally, inspecting outputs for policy violations using external guardrails can help maintain security and integrity. Next, we'll explore vector and embedding weaknesses, where malicious content can hide within your retrieval augmented generation corpus, further emphasizing the need for vigilance in managing these systems. As we shift our focus from the importance of system prompts, let's delve into another critical area: the vulnerabilities associated with vectors and embeddings. In today's digital landscape, malicious content can easily infiltrate your retrieval augmented generation, or RAG corpus, as well as multi-tenant vector databases. This poses significant risk, as it can poison retrieval results and compromise the isolation of your data. To mitigate these threats, implementing permission-aware vector database with strict namespace partitioning is essential. It's equally important to validate and scan all documents to detect hidden text and images. Regularly monitoring retrieval logs allows you to label sources and access levels effectively. Additionally, staying informed about embedding and version research can help you avoid storing sensitive text verbatim. Next, we'll explore the implications of misinformation and the dangers of over-reliance on AI-generated content, particularly how confident yet incorrect answers can lead to serious legal ramifications. As we transition from our discussion on vector and embedding weaknesses, let's delve into a significant concern: misinformation and the dangers of over-reliance on AI systems. It's crucial to recognize that while AI can deliver confident answers, these responses may not always be accurate. This can lead to serious repercussions, such as legal liabilities, safety risks, and considerable damage to brands' reputation. To mitigate these risks, it's essential to implement retrieval augmented generation using trusted and verified sources. Providing citations helps users discern the reliability of information. Additionally, requiring human verification in high-stakes situations can substantially reduce errors. We also encourage designing user interfaces that clearly communicate the limitations of these systems and educating users about what AI can and cannot do. Finally, adopting secure coding practices is vital to prevent vulnerabilities. Now let's explore another critical issue, the threats posed by unbounded consumption. Building on our previous discussion about the challenges of misinformation, let's explore another critical aspect of large language model usage, unbounded consumption. This concept highlights the potential threats posed by excessive or reckless integration of these models. Imagine a scenario where a service is overwhelmed by requests leading to a denial of service, or users face exorbitant costs due to expensive API calls. This is what we refer to as denial of wallet. Additionally, we have to consider risks like model extraction attacks and side-channel information leakage, which can compromise sensitive data. To mitigate these threats, implementing protective measures is essential. This includes setting rate limits, establishing quotas, and utilizing timeouts. Capping input sizes and throttling resource-heavy tools are also vital steps. Monitoring usage patterns can help us adapt and ensure smooth performance even under peak demand. Next, we'll delve into some red team test ideas, starting with prompt injection techniques. Stay tuned. As we transition from understanding the threats posed by unbounded consumption, let's dive into some practical red team test ideas focused on prompt injection. First, consider summarizing a web page that contains hidden instructions, creating a scenario where we attempt to exfiltrate a fake token. This exercise will help us demonstrate how effective output filters can block such attempts. Next, we can explore RAG poisoning by uploading white-on-white text. This highlights how seemingly innocuous inputs can create recommendation bias in hiring systems. We'll also examine the risks of improper output, where a model might return malicious script showcasing the importance of content security policies and encoding fixes. Lastly, we'll simulate denial of wallet scenario by sending bursts of expensive requests, illustrating the effectiveness of rate limit dashboards and cost controls. Now let's look ahead to our implementation plan. In the next segment, we'll outline our foundational steps for the first 30 days. As we transition from discussing red team test ideas, let's delve into our 36 to 90-day implementation plan. In the initial phase, our focus is on laying solid foundation. This involves enabling key security measures like rate limits and size caps, as well as establishing robust content security policy. It's crucial to remove any open-ended tools to enhance our security posture, while also implementing per-user auth for better access control. Logging all tool calls and data retrievals is another key step during this period. It helps us maintain oversight and ensures we can track any anomalies. Moving forward in the next phases, we'll build on these foundations with more advanced controls and aim for full maturity in our security strategies. In our next segment, we'll explore free standards and checklists, particularly focusing on the OWASP application security verification standard, which will guide our validation processes. As we transition from our implementation plan, let's delve into some invaluable resources that can enhance your security measures. First up, we have the OWASP Application Security Verification Standard, a crucial framework for validating your security practices. It provides a structured approach to ensure that your applications are built with security in mind. Next, there's MITRE Atlas, which offers a comprehensive catalog of AI and machine learning attack techniques. This is essential for understanding potential vulnerabilities in your systems. We also have the Cyclone Software Bill of Materials, which helps you track components in your software, including a specific focus on machine learning through the ML Bill of Materials. Finally, don't overlook the OWASP LLM Tip 10, which outlines key security risks associated with machine learning and large language models. Now let's explore how these resources integrate into architecture and threat modeling. We'll reference our detailed architecture diagram in the appendix to guide you further. As we transition from discussing the OWASP asks and its vital role in application security, let's delve into the importance of architecture and threat modeling. Referencing the detailed architecture diagram in the appendix, we can visualize the various threat surfaces within our system. This includes user interfaces, RAG systems, tool integrations, agent frameworks, and data pipelines. By utilizing this diagram, you can strategically position security controls at each system boundary and interaction point. It's essential to identify where to implement key security measures such as authentication, authorization, input validation, output encoding, and monitoring throughout your entire LLM application stack. This systematic approach not only fortifies your application, but also ensures robust defense against potential vulnerabilities. Now let's transition to our key takeaways, where we'll emphasize why treating LLMs as untrusted users is crucial in maintaining security integrity. As we move from our discussion on architecture and threat modeling, let's delve into some crucial takeaways regarding the safe use of large language models or LLMs. First and foremost, treat LLMs as untrusted users. It's essential to never take model outputs at face value. Always validate, encode, and sanitize them before integration into your systems. This practice minimizes risk significantly. Next, apply the principle of least privilege across all components. This means giving only the necessary tools and permissions to each part of your system, thereby limiting potential vulnerabilities. Additionally, ensure you validate everything coming in and going out. Implement thorough input filtering and output inspection to catch any anomalies early on. Lastly, keep a vigilant eye on costs and usage to prevent what we call a denial of wallet attacks. Proactive monitoring and alerting are key to maintaining control. Next, we'll explore the credits and licensing for this essential content. As we transition from our key takeaways, it's essential to recognize the foundations upon which our guidelines are built. This slide highlights the credits and licensing for our content, specifically adapted from the OWASP Top 10 for LLM Applications, set to be released on November 18, 2024. This resource is shared under the Creative Commons Attribution Share Alike 4.0 license, which means you're free to use and adapt the material as long as you give appropriate credit. When you do share or create derivatives, remember to follow the same licensing terms. Attribution not only respects the original creators, but also fosters collaborative environment in the community. For complete reference details, you can find them in the video description. Now let's move on to explore how we can effectively implement these principles in real-world applications.